so kind to unmute your cameras and your microphones, and apologies for this slight delay. We are in the Manufacturing 4.0 webinar series, and we try to provide high-tech webinars, and as you have experienced, it's a very low-tech start. So again, apologies for this intro. Frank, would you also be so kind to mute your camera so we can all enjoy, let's say, our guest speakers. We are still accepting our, let's say, audience. We have, unfortunately, had some problems with the initial link, and we are reaching out to all the guests to reconnect on this Zoom platform via this new link. We have already more than 30 participants joining. So I would like to wait another 5 minutes. So I know I'm stealing time of your busy schedule, everyone. We do apologize, but we want to wait another 4 minutes to see if we can reach at least the 50, let's say, pre-assigned participants, and then we will start. I'm sure the wait is worthwhile, because what you will hear from our friends of KUKA Robotics is worthwhile and very interesting as well. If you're in the manufacturing, if you are working with robotics, if you are considering automating your product processes, this would be of interest to you. We will have ample time to ask questions. There are also some videos incorporated. Like I said, please bear with me another 2-3 minutes, and then we'll start, and then I'll come back to you to officially open this webinar. Thank you, and apologies for this slight delay.
No arrangements next again.
Great seeing you, Ellen, as well. It's already 6:16 here in Bangkok. I know we have an international crowd joining our webinar this afternoon. So thank you all for joining this webinar, which is actually the NTCC Manufacturing 4.0 webinar series. In the past few weeks, actually 2 months almost, we have been conducting similar webinars to, let's say, share knowledge, best practices, but always looking at, let's say, the newest technology, the latest inventions and innovations. So today is nothing contrary, because we are going to talk about robotics, and the application, let's say, in the manufacturing process. Before we will give the audience, which actually we have 3 guest speakers, and we have a moderator, Kunaramon, sitting with us here at the Dutch Embassy, an official welcome here from Bangkok, from the NTCC office, to all the viewers who are not familiar with the Netherlands Thai Chamber of Commerce. We have an office in the Dutch Embassy here in Bangkok, and our main task is to look after the interest of, let's say, Dutch Thai business community. But as of today, and this is also a question I have received, we're not only focusing on Thai or Dutch, because a Dutch webinar and we have a German company. How is that possible? Well, it is very good possible, because when we looked around in the region and we were always searching for the best quality and the best, let's say, available speakers, we found this German company, KUKA Robotics. Martijn Smit, who is one of our board members, has been actively engaging them, and we are very pleased that today's webinar is being conducted with 3 high-ranking managers, MDs, even CEO level of this KUKA robotics company. They are based not only here in Thailand, but also from Malaysia. So this is truly an international webinar, and it's also part of a hybrid event. We are still accepting participants. So already we have neared 40 guests, I see. So without further ado, I will say a few welcoming words because you have listened to me more than enough, and I've been talking to gain some time, as you have realized. We are today having Kunarumon of KUKA Robotics as the moderator. That means she will be introducing the 3 guest speakers, which is Alan, the first one actually in line. There are quite a lot of slides. There are also a few videos incorporated in the slide presentation, so you will hear a lot of information. Now, what we try to do with today's webinar is to showcase practices, applications with live situations. So you will see examples here in Thailand, you will see even in Malaysia, and I believe Taiwan is also incorporated. So you will see various operations where robotics, and in this case KUKA, has been introduced and helped automating the processes. Now, what I will now do is I will ask Kunarumon to basically take over from here. So she'll be sitting on the same chair. I will make a move. My only last remark is let's make this an interactive webinar with regards to asking questions. And if you have any questions, please raise them in the functionality, in the chat functionality, so you can reply and ask any questions. We will monitor them. And at the end of the 3 presentations, we'll have ample time to zoom into your questions. So without further ado, Kunarumon, please take over, and thank you again all for joining, and I wish you a very interesting, informative webinar. Kap kun ma kap.
Thank you, Mr. Hans. Hello, everyone. Let me share my screen. Hello everyone, and welcome to today's session hosted by the Netherlands and Thai Chamber of Commerce and KUKA Robotics. Well, my name is Narumon Tongkam from KUKA, Thailand, and I'm a moderator in this webinar. Today we are presenting Embracing Robotic Applications in Boosting Economic Performance within APeC, presented by representatives of KUKA Robotics APeC region. I'd like to introduce today's presenter, Mr. Alan Pham, Chief Regional Officer, Neoh Sin Joo, Regional Sales Director, and Tawiwat Reongpunyaroj, Chief Executive Officer of KUKA Thailand and Vietnam. But just a little housekeeping before we get started. If you have any questions during the presentation, there will be a Q&A session after presentation. Please bring up your question by typing them in the chat box, as we like to hear from you and are pleased to answer your questions at the end. For those of you who just joined us, welcome. Now, without further ado, we will turn our time over to Alan Pham, who is Chief Regional Officer of KUKA APeC region. Alan has experience in automation industry for more than 15 years. His area of expertise includes building a great team to drive profitable and sustainable business growth, formulating and driving winning strategy, and increasing robotic market share for Asia Pacific countries. Before KUKA, he worked in various senior management roles in companies such as Estago, Atlas Copco, etc. He is blessed with one beautiful daughter. Hiking and running are his strong passion. Ladies and gentlemen, please welcome Alan Pham.
Hello, good afternoon. Thank you, Narumon. So can you go back to one slide, please? Or one or two slides. And just the industry 1.0. Okay, so good afternoon again, everybody. Thank you for joining this session with us. So I will start off with this session with defining what is Industry 4.0, at least in the context of robotics world. Next slide, please, Narumon. Okay, so so this is Industry 1.0. So basically, it's the first industrial revolution. The first industrial revolution happened between the late 1700 and early 1800s. So during that period of time, manufacturing evolved from focusing on manual labor performed by people and aided by work animals to a more optimized form of labor performed by people through the use of water and steam power engines and other types of machine tools. This is the part whereby us human beings step into the new era from using cows, using horse to steam engine locomotive, basically. Next slide. Thank you. And this, ladies and gentlemen, is Industry 2.0. So in this picture, or this small animation, you see the cars going on a conveyor belt, moving on, being mass produced. So all this happened during the early part of the 20th century, whereby a man, most of us know Henry Ford, he was thinking of a way to produce cars in a very efficient manner. He got an inspiration from a slaughterhouse of cows, and he was doing reverse engineering how to make things assemble in a very fast, efficient way. The introduction of electricity enabled manufacturers to increase efficiency and help make factory machinery a lot more mobile. It was during this phase, the Industry 2.0, that mass production concepts like the assembly line was introduced as a way to boost productivity. Next slide. Perfect. And over here, this Industry 3.0. So basically, this third industrial revolution is all started in the late 1950s. And the third industrial revolution, this slowly began to emerge as manufacturers began incorporating more electronics and eventually computer technology into their factories, mainly CPU, right? That all of us know. So it processing become a lot more doable, a lot more feasible compared to the early 1900s. Now in 1950s, this is doable from our point of view. During this period of time, manufacturers began experiencing a shift that put less emphasis on analog and mechanical technology, and we move on, transform to more digital technology and automation software. So during this time, World War II happened. You have a lot of PLCs. You have people like Rock Automation, Siemens, Schneider Electric, Japanese folks, and Mitsubishi, Omron. All those manufacturers come out with the Industry 3.0 revolutionized products in the market for automation at least. So thank you. Industry 4.0, please. Next slide. Perfect. And over here, you see Industry 4.0, or we call it the fourth industrial revolution. So in the past few decades, a fourth industrial revolution has emerged. So some countries call it Industry 4.0. In our world, we call it more industrial Internet of Things. So in the US side, we see people call it Internet of Things. Some other countries, such as Asia continents, we call it China, let's say for example, China Manufacturing 2025, and so on. But basically, this revolution emphasized on digital technology from recent decades to a whole new level with the help of interconnectivity through the Internet of Things, access to real-time data, introduction of cyber physical systems, and so on. This Industry 4.0 offers a more comprehensive, interlinked, and holistic approach to manufacturing. It connects physical with digital, meaning your robots, your nut runners, your tool changers, your grippers, everything with digital, and allows for better collaboration and access across departments, partners, vendors, products, and of course the people working, either the shop floor, the guys working on shop floors, the guys working on the management office, and so on. Industry 4.0 empowers business owners to better control and understand every aspect of the operation and allows them to leverage instant data to boost productivity, improve processes, and ultimately drive growth. Next slide, please. Thank you. So over here in the ecosystem of KUKA, at least for us defining Industry 4.0, for sure on the left side you see that KUKA is a global multinational company with more than 3.2 billion euro revenues. We are very heavily, deeply involved in industrial automation. We provide robots, robots for sure. We are in the digital products business and service for the robots, especially. Over on the orange color box, you see that we are involved in providing robots, which we take pride to provide one of the best robots in the world. Line building, logistics, production, machine building, industrial automation, and so on. Along with the growth of Industry 4.0, which we prioritize as well, we are also acquire companies related to able to let us enhance our footprint, our understanding of Industry 4.0. For example, a Finnish company called Visual Components is also now part of KUKA Group with almost 20 years in the business, whereby we do 3D manufacturing simulations. So a lot of our customers globally had gained the chance, the opportunity to actually have a very good manufacturing simulation software to make sure that their products, their manufacturing line is designed according to their requirements. Not to say the least, we also acquired another company called Device Insight, which is also now a big part of the umbrella for KUKA groups, whereby this acquisition allow us to be able to be integrated much more into turnkey IoT solutions. And we already have more than 1 million connected devices. It can be devices such as a toilet cleaning machine or floor cleaning robots and so on, whereby we see that this is going to let us be a lot more advanced, a lot more integrated into the Industry 4.0. But this is something, Industry 4.0 is a big umbrella, it's a big ecosystem. KUKA for sure, we cannot do this alone, although we are a big part player of it. We are also forming an alliance with SAP for sure to lead this strategic industrial alliance. So far right now, we have more than 44 members contributing to this customer-centric interoperability. Thank you. And next slide, please. So for KUKA, trying our ultimate best to support all our customers in Asia Pacific region. So we have offices, as you can see here in the map, either it's Australia, in Japan, Yokohama, Korea, we have an office as a tech center to support the customers, Taiwan as well, in Taipei. In Southeast Asia, we are all across Vietnam, Thailand for sure, Malaysia, and Singapore. So one of our key strategy will be not only to provide good robots as a product, but we want to stay close to our customers. We want to make sure all the legal entities you see here, we have professional service team to support the customers. So hopefully all customers can enjoy this customer-centric approach from us. Thank you. Next slide. So how is robotics playing in the world of Industry 4.0? For sure, it's part of automation drive. We do see that this is actually a report from the latest International Federation of Robotics. In terms of cumulative operation stock in the world, right now you can see the CAGR of at least more than 10 to 15% every year. So the world is for sure step by step leap bouncing to employ, to adopt robotics in their everyday life. Next slide. Over here, you can also see that in terms of region distribution, Asia and Australia for sure outweighs all the other regions in the world, such as Europe and Americas. I think one of the key biggest region that's growing for sure is Southeast Asia, and Thailand being one of the big part player of this. So we do see a very encouraging data, encouraging numbers of customers and end users adopting to this technology. Next slide. So over here, in terms of application-wise, you can see the automotive industry, automotive, electronics, metal machinery are a big part, a big chunk of the industry employing robotics technology. And the other big part is unspecified, meaning it can be anything. It can be medical, it can be education, it can be aerospace, and so on. But generally, the trend is there. And we are very encouraged and motivated by this. Next slide, please. And this will be in terms of applications. So a lot of application in handling and welding for sure. It is part of the drive we see in automotive and electronics. No surprises there. And we continue to see a big trend of positive development over in these sectors. Next slide. Okay, I think this will be my last slide before I pass on to Neoh, the sales director for Asia. So basically over here, you can see on the left side, this Industry 4.0 basically is establishing a digital record. So the reason people want to do this is for audit purposes. We want to analyze and visualize the data, collecting all the data from the robotics world, from the peripheral around the robots as well, and last but not least, generate a certain movement. Right. In terms of the right picture here, basically is a snapshot of how we see the Industry 4.0 landscape. Is about connectivity, it's about process optimization, it's about process flow and quality, and last but not least, new business models. But from my point of view, 15 years plus in the industry, I see many companies try to adopt Industry 4.0 in their day-to-day life. And I think one of the key things for the managers, the key takeaway here from my side at least, is two main reasons for Industry 4.0. One is the ability for you and your team to shorten the reaction time, either to shorten the time for maintenance, for reaction, either shorten the time for quality issues, to shorten the reaction time to change a new process for a new model for your customers, or to change a supplier because if a supply chain have issues. And it's all about shortening the time to react. Of course, the last and not least thing will be for legality, for audit purposes, which is becoming more and more important in our day-to-day life as consumers wants to trust the factories or the custom or the suppliers they are buying product from. So hopefully all the customers here, the audience here can enjoy the journey of adopting Industry 4.0 into their day-to-day operation life. I'll pass on the next slide to Neoh Sin Joo. Thank you. That'll be all from my side.
Well, thank you, Alan, for your information and presentation. Now, let's move on to our next key speaker, Neoh Sin Joo. He has more than 23 years in robotic and automation industry experience, and he joined KUKA since December 2012. He held various leadership positions such as CEO of KUKA Malaysia and Southeast Asia, and deep involvement into ELE industry, and interim CEO of KUKA Taiwan. He currently leads the sales division to defining and planning with regional sales strategy, developing robotics business for the region, and he's happily married with 2 children. And his passion includes Qigong, yoga, cycling, and reading. Neoh, please proceed.
Yeah, thank you, Vi, and thank you, Alan. So good afternoon all, and it's my pleasure to share with you. So over here, actually, I would like to present to you that regarding some of the case study and also application regarding Industry 4.0 that we have been through or we have been through with our system integrator or system partner. Next page, please. Next page, please, Vi. Yeah, it's regarding case study and application. Next. So audience, actually, if we imagine we talk about Industrial 4.0, sorry, 1 page back, please. Yeah, is we will imagine that if we go to Industrial 4.0, most of the people they were sorry. Can you go to the next page? Okay. So sorry about the interruption. So we are talking about, if we can imagine, if we go to Industrial 4.0, most of the people will imagine, you know, is a dark factory, and the factory actually full of robot, you know, and AGV, they are running by themselves, and the production order is already run through the whole factory by itself. And then, you know, you just collected the finished good outside of the factory. I think that is the ideal case if we all want to go into the Industrial 4.0. And also that is the situation that actually we are looking forward to. But for today's shop floor reality, as I show you over here, one of the photo, you can see that actually until today, most of the company is still going on with this kind of reality. You know, it's a standalone machine together. Next page, please. So over here, actually, I take a CNC machine as an example. Although in KUKA, we do not deal with CNC, but CNC, as most of you, I think from the manufacturing side, you already know, that is one of the key process that you needed, you know, to forming the product, or even to come out with the shape of the product. So it's one of the critical machine that we need in our process of manufacturing. Next page, please. So I would like to go extreme case. You see that just now we come from the photo that talk about the reality of today shop floor, which is standalone one machine. And you can see that over here, actually, there's a lot of automation or digitalization that we can do for the single machine. So over here, you can see it depends on the manual or the human to operate it. But imagine that if this standalone machine, that we connect them all together to become a whole, go into automation or digitalization, then it will be different way. Next page. So over here, just now I mentioned that although KUKA, we are not dealing with CNC machine, but over here I would like to provide some of the example to all the audience that we are doing quite a lot of automation actually connecting to the CNC machine. Such an example on the top left corner, you can see that the robot have been used, KUKA robot have been using to loading, unloading the casting machine, casting part to the CNC machine. And then you can see that from the lower part of the left side, actually the robot is doing the secondary process that beside the CNC machine do, he itself also loading the gripping the part to the tools, and then to do the trimming process or drilling the holes. Then on the right down corner, eventually there's a robot integrate into the CNC machine itself to do the tool changer. So you can see that although KUKA ourselves, we are dealing with robot, but actually we are dealing with all the key machine in the process manufacturing. Next page. So over here, like just now, Alan also mentioned in the Industrial 4.0, we ourselves, actually, we cannot do it. We have to do it together in the industry. That's why over here, actually, KUKA, we actually partner with some of our integrator or machine builder. We call them our official system partner from the industry to work together by utilizing the robot or other machine to go towards Industrial 4.0 for the process manufacturing. So over here, KUKA, actually, we are relying on our product or service, or even our ready-to-use or standard solution, or some of it, even we have a custom specific solution. So to go to the end user or the end customer. Of course, all this involved in the key industries such as automotive OEM, automotive tier 1, electronic, general industry, and consumer good as well. Next page, please. So this is one of the video example to show you that how we work with our system integrator, system partner in KUKA, Thailand. Please enjoy the video for about 2 minutes.
AI เทคโนโลยีนะครับเราเป็นบริษัทที่เรารับออกแบบสร้างเครื่องจักรนะครับในอุตสาหกรรมโรงงานนะครับหลักๆของเราเป็นบริษัทที่รับออกแบบนะครับก็คืออุตสาหกรรมหลักๆเนี่ยก็คือเราจะเป็นอุตสาหกรรมรถยนต์นะครับในฐานะของเราที่เป็น System Integrator นะครับเรามีหน้าที่ในการสร้างและออกแบบระบบการผลิตให้กับลูกค้าหัวข้อแรกคือเรื่องของระบบความปลอดภัยซึ่งเราต้องคำนึงถึงเป็นระดับต้นๆในปัจจุบันนะครับในบางลักษณะงานที่มนุษย์เราหรือคนเราในโรงงานอาจจะทำงานมีข้อจำกัดมากกว่าหุ่นยนต์เช่นในพื้นที่ที่สกปรกหรือพื้นที่ที่มีอันตรายเช่นอันตรายจากสารเคมีความร้อนลักษณะอย่างนี้เป็นต้นนะครับนอกจากนั้นเราต้องคำนึงไปถึงเรื่องของproductivity หรือผลผลิตนะครับที่จะเกิดขึ้นอย่างสม่ำเสมอปัจจุบันนะครับลูกค้ามีความต้องการเครื่องจักรที่เป็นแล้วก็เราเองจะต้องออกแบบให้ในเรื่องของการลดเวลานะครับแล้วก็ลดแรงงานคนนะครับเพื่อความต้องการของลูกค้าเพื่อในการแข่งขันของตลาดของลูกค้าครับเนื่องจากว่าการลงทุนใช้ระบบในระบบการผลิตนั้นมีการลงทุนค่อนข้างสูงเพราะฉะนั้นเราในฐานะผู้ออกแบบและผลิตนะครับระบบการผลิตให้ลูกค้าเราต้องคำนึงถึงความเหมาะสมและการผลตอบแทนของการลงทุนให้ดีที่สุดนะครับไม่ว่าจะเป็นทั้งเรื่องของต้นทุนที่การผลิตที่จะลดลงนะครับการรักษาระดับคุณภาพของผลิตภัณฑ์ให้กับลูกค้ารวมทั้งการส่งมอบนะครับให้กับลูกค้าที่มีความศักยภาพและประสิทธิภาพที่มากยิ่งขึ้นครับเราได้นำโรบอทกูก้าเข้ามาในรายผลิตของอุตสาหกรรมการเกษตรมีการหยิบจับถุงน้ำตาลถุงปุ๋ยเคมีนะครับซึ่งเป็นระบบของ Predictive ครับก็คือในปัจจุบันเราเอาKUKA Robot มาทำการหยิบจากชิ้นงานที่เป็นลักษณะเป็น tag roller.
We invested in a lot of CNC machine, CNC lathe, 5-axis machine, a lot of high quality machine. Also, the people side, we have our internal training system for our marketing staff, our engineer design, electrical, mechanical, also the assembly team. We try very hard to find the right and best solution for our customer, and automation and robot is the right answer for the industry. We have to be able to create more automation with higher capability, with lower cost. I think this is the main challenge for us. I think in the future also we will expand more and more because there are so new opportunity for us.
Orange Intelligenz.
Thank you. Yep. So if we talk about Industrial 4.0, right, it's not limited to the multinational or big enterprise only. Even the small and medium enterprise, they would like to go into Industrial 4.0 over here. So I also pick up another case of a small and medium enterprise, which is operate in APeC region in Malaysia, which they are dealing with what we call 3D industry. That means it's demanding, dirty, and dangerous. And they are such a small company, only have 10 workers, and they are involved in construction industry as well. And we have a system integrator that they call SmartSense. They try to do a palletizing system to this company. Next page, please. So on the palletizing system, actually they are utilizing the sensor, you know, using the 50 kg transport, the bag transport through the conveyor, and then with the sensor transmit arrival of the bag, the robot pick up and then do the palletize the bag on the pallet, and then all this information regarding the bag condition or the volume of the bag or even the number of the bag on the pallet, all these have been uploaded to their cloud or their server. And all this connection also connect to the mobile device such as mobile phone or into their computer or iPad or the tablet. So eventually, from time to time, real time, they can monitor the situation in the factory. So they get all the data regarding the volume of the production, how is it, how many pallets today they completed, how many kg of the product material have already finished and palletized by the robot. So eventually, this is one of the Industrial 4.0 solution that we work together with our system integrator, SmartSense. Thank you. Next page, please. So just now I show you an example regarding the small and medium enterprise. Now I take another example is a multinational company who also try to increase their Industrial 4.0 investment as well. This company actually in Taiwan also stay in the APeC region. It's called HOTA Industry, and the company size is about 1,300 people. And they have we have worked together with an integrator called DSA to complete the whole system for them. So the opportunity we see over here actually for the customer is process efficiency by using manual, quality issue as well, safety and labor. So by using the robot and the automation and go into the Industrial 4.0 with some of the sensors, they will be encountering, take care of their quality problem, the error created by human, and also increase their efficiency. Next page, please. So over here, eventually, before we start with the real planning, right, we actually do a simulation together with the integrator and then to show the performance of the whole automation line after it built up to the customer. So from there, we actually, this process, we have two separate sections. One is the front end process, which is using the gantry robot to do the loading, unloading, and also unload to the conveyor system, which is when come to the conveyor system, we have two robot KR22 actually doing the separation and then loading into the back end process, which is after that go into the CNC machine by another robot as well. So over here, actually, before the line have been set up, the customer have all the requirement and all the performance by through this simulation. Next page, please. So over here, we have a video to show you that how's the performance of the line and also some words from the owner of this factory. Please enjoy the video.
With more than 1,500 employees worldwide. Our core business is developing and manufacturing powertrain products for transmissions and reduction gearbox components and assemblies. KUKA has several manufacturing facilities, and right now we're in the most advanced and automated production facility here in Chiayi, which is located in the south of Taiwan. In here we have only one-piece flow production lines that are fully automated with gantry loaders and robot arms. We have integrated inline sensors for immediate detection of quality deviation and have automatic correction in the process. The RFID is also built into the line so that we give every part an identification and keep full traceability of all the parts being produced. Automation greatly changed our production method. In our other production facilities, we arrange our production by workstations or standalone automations for different processes. Sometimes the parts get delivered to our outsourced supplier and then are sent back in-house for us to finish up the processes. This can sometimes take months or weeks to finish a batch of production. And with the parts being transported in and out, there's usually more quality concern. As we utilize more and more robots over the years, we realize there are a lot of advantages associating with using robots. First of all, you save almost all manual labors for loading and unloading. Then, by avoiding human errors and with 100% inline inspection after every key processes, you're able to keep a high quality rate and thus reduce quality cost and potential scraps. The robots also greatly increases our production efficiency, and it helps us keep a stable capacity. Compared to months and weeks of manufacturing lead time, now it takes less than 2 minutes to finish a part. With full traceability, we're also to pull out all records of the parts being produced, and then you will have all the information just in case any investigation is needed later. Overall, we're very happy with the automation solutions, and we're definitely looking forward to setting up more automatic production lines.
So thank you very much. So here is the end of my presentation. Before I pass to Kun Tony, our CEO of KUKA Thailand, I would like to summarize that Industry 4.0 is already started. No matter whether it's a small, medium industry or multinational company, they are looking forward for such automation to be going on and involve themselves in the Industry 4.0. Thank you very much. Thanks.
Thank you, Neil, for those interesting case studies. Now it's time for our last presenter, Tawiwat Reongpunyaroj, or our lovely Tony. Tony leads KUKA Thailand and Vietnam, whose domain includes strategic business management activities, expanding and building a sustainable robotic business. Tawiwat has more than 20 years of experience in industrial automation and engineering. He held various management roles in Triumph, Atlas Copco, and Schneider Electric. His favorite pastime includes running, playing golf, and football. He is also musically inclined and plays drums and guitar. Tony, please, right to you.
So thank you, Vi, for the introduction. Can you hear? Okay, so good evening, ladies and gentlemen. So it's nice to meet you all. Next slide, please, Vi. Yeah, now I would like to talking about the step to embrace Industry 4.0. Next slide, please. Actually, at first we have some video, but to shorten the time, so we cut the first one is some kind of the introduction of Industry 4.0. To implement Industry 4.0, actually they have to done step by step. It's not just the big step in the one time. So for KUKA, we define the step into 5 steps. The step 1 for Industry 4.0, the data is the key. So the step 1, we have to do connectivity and make the access onboarding. In the present, actually it's much easier than before. Before in the past, we have a lot of investment to do the connectivity because of to do wiring, installation, and everything. But currently, we also can do by wireless connectivity. And the other thing is like the communication will be more standardized. So for the industry, normally we use they call OPC UA, and most of the devices, smart device, smart sensor, or even machine or even robot have this kind of connection. So you don't need the gateway to convert the communication and to make them communicate together. They just connect to the network and you can get the data. So, and next for the step 2 and step 3, after we got the connection, so the simplest way, we can do the transparency, make it visualization, and can getting some alarm on the machine error. And for the step number 3, you just do that simple calculation to calculate some kind of the performance availability, quality, and also cycle time. Or you even do the rule-based notification to inform the worker how to take further action when there are some alarm coming. For these 3 steps, actually, there are a lot of, there are many factories is already implement this kind of thing. Even in Thailand, Vietnam, or in the region, already have these 3 steps. And it's really simple. You can do just connecting and use some software like SCADA software to do to get the visualization and alarm and some performance monitoring. But for step number 4 and number 5, that is much harder. Yeah. For step number 4 and number 5, it will be like statistic method, the calculation, and also for the automatic detection for the upcoming event. Or the fifth step is will be like machine learning and AI to take some kind of the predictive event like predictive maintenance and do some more calculation. For the fifth and fifth step will be more complex, and it's not only the shop floor itself, it will become to connect with many parties. For example, like the office automation or the planning software like ERP or MES. This will be really difficult for the small and medium enterprise. But for big company, yes, there are some degree of the implementation. But for small and medium enterprise, there are the owner has some doubt how to implement it, and sometimes they're not so sure that is it worth to do it or not. So most of the owners still have some kind of the outcome they can get it from to implement Industry 4.0. Next slide, please. This is one of the big overall picture that I like. This is the reference from PricewaterhouseCoopers research. This is the outcome if we implement the smart factory or digital factory by implementing Industry 4.0. They have a lot of features that you can get to be the benefit to the factory. I can grouping in around four groups. The first group we call digital twin. Digital twin, I heard that in NTCC you plan to have another session for digital twin. So for digital twin, will be you can make the simulation and you can do the commissioning by software in the PC before you doing install in the real thing. So it will be shorten the time of the setup, shorten the time of the commissioning. Even you can get the best parameter for the tuning in the PC to use in the real life. That is to be the benefit of the smart factory. The second thing is visualization, track and test. So you can see the product, where's the product in the process, and where is the work in process, and also like what is to integrate with the planning, so you will know that when is the product will be finished to inform to the customer order the lead time to the customer. And the third thing is the optimization. For example, like predictive maintenance, like the process automation, like the process optimization, quality optimization, using the big data and doing the algorithm of the machine learning and AI to find out how to tune up the process to be optimized in a good way. Next slide, please. Yeah. This is some from the research. They show that in the today, many of the company already implement some of the function, some of the feature of the smart factory, and in 5 years they have a lot of plan to implement. For example, like predictive maintenance, like digital twin. For KUKA ourselves, we also focus on the 4 key features that will be implemented in the industry. One thing is a predictive maintenance. In our robot, we also have some kind of the parameter to see when the servo motor or the mechanical device have to be replaced. And another thing is digital twin is one of our focus as well. As mentioned by Alan, so we also acquired the company name Visual Component, that is a software for the simulation for the production asset. So we can do the simulate the process before install in the real time, in the real life. And the third thing is the process about the modular production. With the robot and AGV, you can do flexible production. You can change the route of the production, and you can adjust the way of to produce the product. And the last one is autonomous intra-plant. The main product of KUKA is robot and AGV. So the autonomous intra-plant, intra-logistic is one of our key to help to transfer the part or the product from point A to point B. Yeah, this is the 4 points that we mainly focus. Next slide, please. From what I mentioned before, what is the product look like for the future and to fit to the smart factory? For KUKA, we also focus for sure. Next slide, please. For KUKA, for sure, we still focus on the robot and AGV, but to improve the robot and AGV in the near future. So in terms of mechanical itself, it just make it lighter, faster, and more compact. In terms of AGV, it will be improved, like the battery improvement to make the to operate in longer time. In terms of the controller, it can be faster processing and more connectivity. This is just lovely for in terms of the physical portfolio, but actually another point of view, we also concentrate on digital portfolio as well. Next slide, please. This is the one of the key of not only the product itself, we also focus on the digital portfolio that is we fit for the smart factory or industry 4.0. Next slide. Next slide, please. Yeah, for KUKA, for the digital portfolio, we focus on the 5 steps, starting from design, commissioning, monitor, diagnostic, and improve. For design, for example, like KUKA Sim, this is the simulation software for the digital twin concept. So we can do the simulate the whole process, not only robot, is the whole process to check the takt time and the test all the parameter before you install the real products, the real system. And another one is we call KUKA Expert. KUKA Expert is one of the we call the brain of the service people. Normally we keep all of the information around the world. If when the service or our partner doing service the machine or the robot, they will key in the system, and this system will combine all the data. When someone would like to know some, like when error occur, they just search from KUKA Expert. They will list up the solution that the people around the world, what are they doing, and ranking, like this is the most way to solve the problem. This is the first step, and the future step is not just inform, but they can advise, the system can advise, or even they connect to the robot and solve the problem by themselves. For KUKA Expert can do for design as well, and next also can help for commissioning, and for PCS to make the process the better performance, optimize the process. Remote service is to service by remotely from the office, from KUKA headquarters, they can remote to service to the plant without traveling. It's good for COVID as well, I think this feature. Next. Monitor, it will be more visualization. So we have another feature like KUKA Connect to get the information or information from the robot. Also for, like as I mentioned, predictive maintenance, the temperature of the servo motor, the vibration, and the speed. So we can know and running hour for the maintenance point of view. Another thing is like visual shadow. So for digital twin, diagnostic. So also the same software we can do for diagnostic as well. And the last part is to improve the process, to optimize the process. Next. Yeah, this is some kind of simulation that we can do. The next slide, please. I talked about product already. So what is the plant in the future look like? Next. With the key driver from the advanced technology like additive manufacturing, right, robotic and automation, and also the digitalization and the performance of the controller right now and networking right now. So there's the key concept for plant in the future. We will define in terms of the volume of the production. In terms of small volume, it should be like, the idea is, the concept is, it should be like e-plant in box. This is one of the examples that I found even in Thailand, like 3D printing, metal 3D printing. Now they start to do to produce the part that produce the bone by titanium using 3D printing. In Thailand, we also have in some institute, they start to do that. Just 8 hours, they can produce the part and do some finishing and can use that bone customized for the person. And the size of the production is just like 5 by 5 square meter. So it's very small and very productive and very customization. This is for the small volume. For the big volume, they have 2 scenarios. In one of the scenarios is we produce as a mass production, but it will be very, very cost efficient with the automated, with the smart automated plant, connect everything together, so we can optimize the process and to be cost efficient much more. Another way is will be customer centric plant. So it will be fully customization. They can produce only one product, one piece of product to fit to the customer, and very fast responsive. This is one of from this picture, KUKA also have some concept of plan for the future for the automotive plant in the next video. Yes.
The visionary aspect of the concept is that for the first time we have put into practice the idea of separating production from logistics and are now using software to provide all the logic that the connecting conveyor technology used to bring into the system.
We believe that decoupling means that you don't have rigid production, where only one product is manufactured. Instead, you have the option of designing the product flexibly, depending on the order situation.
Initially, the focus was on modularity. We thought about what it would be like if we made a series of identical cells.
Simply put, there are many omnipotent robot cells that are linked to each other, but the linkages are not rigid. They are completely flexible.
I disassemble the system into its components and reconfigure them as required. And then, similar to an organism's brain, I have the appropriate software to coordinate these components. The greatest innovation is the software that connects the whole thing. The focus is on the modular production cells. This is important. Modular, product neutral, cycle time neutral. The cell itself is product neutral. Only when the cell is equipped with the appropriate gripper does it become product specific.
Where individual components used to be brought to the assembly line, AGVs are now assembled and fill the production cell for this step, completely autonomously, controlled by the software. This is the digitization of production. The AGVs decouple the line. To put it back together again, I need an extremely large software tool, namely our smart production control. This leads to everything interlocking again afterward. The system runs in real time, with a virtual shadow mirroring the real system. I can see if there is a problem, so I can step in and check the component which is clearly designated.
A big advantage of our concept is that because we don't have rigid linkage, we can continue to produce even when a scene is at a standstill simply by reprogramming the material flow. This is particularly interesting for manufacturers who want to produce a large number of different products on their systems, or for customers who don't know yet exactly how the market will develop. For example, it's absolutely suitable for the spare parts business. I can integrate as many cells as I have space for. That can be 10 cells, that can be 100 cells, but that can also be just one cell. The quantity results from the production requirements that I'm planning. With a system concept like this, you can produce anything that can be manufactured because the part that's being produced is its own construction plan. This matrix concept might then be available in sizes 1 to 10. You can say, for example, that for automotive the size is 5, for shipbuilding the size is 10, so that the size of the finished product determines the size of the matrix concept. That's absolutely conceivable.
For us, this is the first step into the future.
Orange Intelligenz.
So, thank you. Thank you. I think next is will become Q&A, right?
All right, I think that was a lot of information. Thank you very much for that. Maybe we can have the last slide, which is the Q&A slide. We have been monitoring the chat box actually, and one question came in, and maybe this is a question for Neoh or for Alan, so you can both basically fight who will be answering this question. And let me read out the question, which is coming from Sander. Let me have a look. Yeah, Ruben Sander, he mentions that Industry 4.0 at this moment is still focusing on processes in factory and plants. I think we have seen a lot of examples today. When will the manufacturing really be connected with the end consumer? Meaning a real production on demand, order a product online, and after completing the order, it will be manufactured. Who from the gentlemen would be able to reply to this question?
Hi, Alan from here. So thank you for the question, Ruben. I think just now in my presentation, I mentioned the way at least I see the Industry 4.0, two main reasons we, the manufacturers or the manufacturers do it. One is for legal purposes, audit, for tracking when you have quality issues, when you want to recall 10,000 cars. Either you want to recall 10,000 cars or you want to recall 500 cars. And these can be, this can be minimize the risk by using, by having good data on hand. The other one is the reduction of time to react, right? And this is part of it. So for example, if you're manufacturing shoes, right? And you're managing thousands of blue color shoes, and your marketing team is telling you the customers tomorrow will prefer black color shoes. Now you need to change your process from manufacturing blue color shoes to black color shoes. And by having enough data on hand, linking the marketing department information through your customer relation management software, to your ERP software, to ultimately your production plants. MES software and so on, and that the time to react, to stop whatever you need to stop for the color mixing, but ordering through your ERP software to the black color supplier for the new colors. So some actually to some extent this had already happened to our customers, But I do see that there's still some way to go before it's fully employed to all the processes and all the other production as well. So that's my answer. Neil will have a similar answer as well, or?
Yeah, Alan, I totally agree with you. If there's, I think, still some way to go if we want to achieve this kind of, you know, you order a product online and then the factory will manufacture, and then after that, the product will be going to you. Of course, today, I would say take a very easy example is like you are ordering a shirt, you know, maybe a Nike shirt with some logo that you like, pick from the website, and then you like to print the logo on the t-shirt. I think this part of the thing, it might be today is already achievable. I believe that some of the Nike or Adidas outlet, they already can do all these kind of things. But if we talk about a car or a machine, which is much more complicated, I do see that in the end of tunnel of the journey, it will happen in this way as well. But the time taken will be longer because the way of you know, building a machine or building our equipment, it takes much more time and the component will be much more. That is the example I can provide. Thank you.
Thank you very much, both gentlemen. In the meantime, we received another new question from Joost. He's asking, what would be the main challenges at this moment for further implementation of Industry 4.0 in Thailand, e.g. infrastructure or knowledge base, skilled workforce, a lack of knowledge within the industry? Is this something maybe Tawiwat could reply to? So what are the main challenges on introducing and implementing Industry 4.0, in particular this country, Thailand?
Yeah, yes, thank you. So actually, it's not only Industry 4.0, even automation. I think one of the problem for Thailand is actually in Thailand, like the system integrator, they have a lot of good skill of programming, but they don't have the skill for the application. It's still lacking because the best, one of the challenge is the implementer. They have to know both the skill of the application and how to implement it. But they just know how to program it, but they don't know the core of the application or the industry. So this is some kind of link that in Thailand we don't have this kind of the company yet. This is one of the challenge. They have like scatter, but they did not combine together. For example, this Industry 4.0 is measured, is the key is one of the lean production. They have a lot, we have a lot of experts of lean production, but they don't know how to implement it with the Industry 4.0. We have an expert for Industry 4.0, but they don't really know what the lean production, how to implement it. So if we can combine or link together and join together, it will be this will solve the solution, but now it's not yet.
Okay, well, thank you for enlightening us in that respect. Another question, which will be also the last question for this platform, from Tutrans to everyone. Who should be in charge in maintenance robotics? The maintenance team in the factory, or is it going to be experts from KUKA actually in control of maintenance?
Maybe I'll answer that. Hi, very good question indeed. I will say it's really case-by-case basis. Mainly saying that if there will be customers that they say that they are going to buy one KUKA robots, they'll be enjoying using KUKA robots. We are very happy for that. But they are saying that they might also want to have a full-blown service contract with KUKA. They might want to have our service engineers every 3 months, every half a quarter, or every year to go and visit them, do some maintenance checking, do some calibration, do some upgrades even, do some software cleaning and so on. So there will be customers like this, but there will be also customers that have been globally buying thousands of KUKA robots from KUKA, especially for example, auto OEM, automotive customers. And they had been using KUKA robots for 20, 30 years and so on. they have a team of competent service engineers doing service for KUKA robots. And for sure, we are happy to support them, but also they are self-competent. All they need is a good original spare parts from KUKA, good warranty terms that KUKA honors, and we continue to provide them trainings or competence upgrades to make sure that they're up to speed on all the new product we launch. So it's really case by case, but for your specific requirement information, feel free to reach out all the Asia Pacific branch officers for more information.
Thank you very much, Alan. I think that's a very nice way to end this webinar. That also allows me to say thank you to you, Alan, to Neoh and Kun Tawiwat, who are sitting actually next to our office here. And last but certainly not least, of course, the moderator, Kun Naramon, sitting next to me.
Thank you.
So thank you all for participating and sharing your knowledge. This was very enlightening. We still have 35 participants zooming in. That means they are all interested in these last minutes. This reminds me that I also should thank Mr. Frank van Baal of ZI Argus, who has been also instrumental in the first approach to KUKA. So once again, thank you to all our guest speakers, and a big thanks, of course, to the audience who are still zooming in. I hope this was learningful. We have recorded this session, so if you would like to have the recorded version, by all means, please do send us an email. We can also connect you to either Alan, Neoh, or Kun Tawiwat, whoever you would like to connect with. We are here as the connector. That's the job of the Netherlands Thai Chamber of Commerce. And last but not least, please stay tuned for any upcoming events. I just wrote down 2 upcoming webinars. So we have on the 15th of October, it's actually more like a hybrid event. It's a company visit. We're gonna visit APeC on Thursday, 15th of October. And that is more like knowledge sharing within, let's say, the manufacturing group. For the Thailand-based members, more than welcome to participate. And then at the end of October, the 29th to be precise, the Dutch TNO group will be sharing an insightful and an innovative technique which is used in the logistics sector, and that is called serious gaming. Now, we all know gaming and computer gaming, but this is a serious gaming. This is a new technology which is currently being used, and a lot of, let's say, field research has been done. So we are very much happy that TNO will be sharing their reports and their insights. So the 29th of October, everyone is more than happy to share and to knowledge and to zoom in, and we will provide you with the Zoom link. Once again, thank you for participating. Apologies for the late start. We are now exactly 1 hour and 5 minutes into this presentation. I wish you a very nice evening wherever you are in the world, and thank you for zooming in to the NTCC webinar. Bye-bye, everyone. Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you.